the stuff we put up and everything like that. Okay. All right, we're recording. Turn my original sound off. It occurred to us as you begin to try to like look at some of these, the next few, the machine learning people we have coming in, these are all built as Max objects, and they're going to be very useful, I think, because we've been making Max our platform for looking at the data. But it occurred to me that, we never really took time to show you some stuff about Max MSP that might be useful. So some of you already know this, some of you have gone through it pretty well, but what I thought I'd do for like 15 or 20 minutes is just take you on a tour of some of my favorite objects in Max MSP. Okay, well, not my favorite ones, but utility objects, okay? Oh, I gotta get out my little cheat sheet.
I feel like I'm Googling it every single time I need to.
Yeah, well, I want to show you why you don't have to Google it too. Okay?
Oh,
so yeah,
excellent.
All right, there's a better way, believe me. Oh, I'm using home tickets. Jeez, I have like sweat running down into my eyes.
The reception was on one side?
What's that?
The reception was on the main campus?
Of course. Yeah. No, I've done this for so long. It occurred to me, Elizabeth, the music librarian, she and I are very close friends. That's why I wanted to be there. And she came a year after I did at Columbia in 1988. I was here in 1987. 35 years, guys. Yeah, get off of my lawn. Okay. All right. So let me just bring up a Max test. And this is going to be kind of ridiculously simple, okay? But it hopefully will be kind of useful. Oh, I got to share my screen here. Hey there. You haven't missed anything, believe me. You just missed me grumbling about how hot it is. So, all right, so share screen. And I'm going to go down here to share sound and say stereo. Yeah, and I'll say share sound, okay? And now I'll share my screen, and I'll say share. Oh, that's my screen. Okay. Yeah, that's right. I think I can close this off. I can close this off, and I can get rid of this. Oh, I don't want to get rid of that. Uh-oh, sorry. There you guys are. Get rid of this. Okay. All right. So let me, I'll get rid of some of this other stuff. I don't need all these terminal windows here. Don't need this thing, okay? And that's my son and daughter about 20 years ago. They're embarrassed that I put that on there. Oh well. Start at Max, and I'm going to show you Max 8 because I think most of you have Max 8, it turns out, okay? So, and these are kind of things that are built into Max itself, okay? All right, now, so I'll start out a new patcher, all right? And again, you've already seen what this Max console thing is about, okay? And you can make it bigger and stuff like that. And that's up here under window. If you lose it, you can always hit this and it'll come back, okay? The other thing over here is that if you hit Command M, that same Max console will appear next to your thing. I'm not sure why they did that. It's kind of annoying to me, but such is life, okay? So let me bring up the Max output again, because we're going to be looking at that for some stuff. And let me just give you, first of all, just a little quick tour of this stuff around here, okay? First of all, when you make an object, there's three things in Max. There's objects, there's messages, and there's comments, okay? And when you make an object, you can just bring this down. And notice that it also says N. This is what I do all the time in class, is I just type N, and then you can type in the name of the object that you're making. Okay, and it makes it, if you're lucky, okay? All right, the messages, same thing. You can type M and you type a message. Objects are the things that do stuff. Messages are data that you give to those objects. That's obvious. Comments are like, if you want to comment things. I'll talk about these in a second. But people go, well, how do you know which object to type in, Brad? Well, that's an arcane art, but I'm going to show you where you can start learning some of this, okay? Over here, okay, there's like package manager and file browser. The package manager, that's how you can like download packages like that thing we looked at last week. I've never used it. The file browser, that's for browsing files. I've never used it. But this thing, objects, if I click on this, it brings up every max object that is there, okay? And just a couple of things to realize. Anything with a tilde after it means that it handles audio. That's like a little sine wavy thing, okay? Anything that says JIT, you probably don't want to use necessarily. That's the Max MSP graphics system. And we've been using processing, for our stuff. Because jitter is kind of hard to use, okay? Hey there. But if you want to take a look at it, it does some pretty incredible stuff, okay? And if you just want to see the max objects and not the signal processing ones, you just click on max. Max for live, if you have Ableton Live and you want to like make a max patch for it, you can do that. We're not going to talk about that, obviously. And this Max MXJ, that's the Java Max stuff, MSP. These are all of the signal processing. Well, basically, you see what it is. So you can actually go through there and say, I wonder what all pass tilde does. Well, let me bring it out here, okay? Now, this is the why you don't have to Google things, okay? If I want to learn about this object, I can Google it, or in unlocked mode, if I hit Option click on a Mac or Alt click on a PC, it brings up the help page. And this is actually a working patch that shows you everything that it does, okay? And you can also look at the details, or you can look at the thing that says question mark, which basically these are things that are related to this object, okay? So this is actually a pretty good system of providing help. And we're going to be looking at those as I go through some of these other objects in a little bit. And this tells you about it, what it does and everything. And somewhere you can actually open up the reference page for it, open full reference. If you click on this, this will bring up the full documentation for this object. And you can read all the stuff that it does, okay? So that's actually a pretty decent thing. And like I said, the really cool thing is that it's a working patch. A lot of times I'll get a patch like this and I'll just simply unlock this patch and then copy and paste it into my stuff because I know it's working, okay? Now be careful, don't save this if you will modify it because then your help patch will be gone. By the way, Steve, these things are the ones that are labeled .help patch. Okay, it's a working max patch, but it has some of this other stuff attached to it, okay? Now, notice that when I looked at that reference, it also opened up this nonsense over here, which tells you all of the messages and things that you can give to it. Again, I think it's kind of annoying, but it is kind of useful. And if you click on this, it'll close this sidebar, they call it. And I think Option I opens it, Command I opens it. Well, that's the inspector. I can't remember what opens it, but something does, okay? All right. So that's kind of really useful information, I think, all right? Now, one of the things that's missing is that when I look at all these objects, okay, let's see, I'm not sure if it's here or not. Let me look at Max. Okay, C, D, E, F, G, yeah, it is there, okay. Some of these objects are graphical objects. Like we're gonna look at the gate object, but there's a graphical version of it that looks like that. Where do you find these objects? Well, they changed it and it's not as good as it used to be. They're kind of hard to find now, but there are some up here that are very, very useful, okay? We're gonna talk about the toggle, we're gonna talk about the gang and the numbers, the sliders we're gonna talk about, and these Max for Live objects, I'm not a big Ableton fan, to tell you the truth, but such is life. I'm old. Okay. I don't think, it used to be there was like one place where all the graphical objects were collected. I don't think that's true any longer, okay? I'm not sure about that though, okay? Yeah. Okay, well, let's look at some of these objects, okay? And yeah, one of the first ones that I want to look at is basically the bang object. And you can get it by just hitting here. Oh yeah, there they all are. They all are there, yeah. These are all these different graphical objects that you can like grab. Oh, I didn't realize they were there. So that's kind of fun, okay? We're gonna grab a bang, or notice I could just type B, see where it says B in parentheses, okay? And that's the thing that we use to trigger stuff, obviously, okay? And it's pretty straightforward. The one I wanted to show you though was load bang. Load bang will generate a bang when you open the patch up, okay? That's useful for if you want to initialize some information in some of the objects, you know. You have to be careful though, because if you initialize things that do bad stuff to max, it will open in a bad state and might crash on you, okay? That's not what's happening to you, Yana, because you don't have anything load banged or anything like that. There's a way to disable load bangs when you open your max patch if this does start to happen to you, but I forgot what it is. You'll have to look it up, okay? All right. The other thing that I've used sometimes that you may not be familiar with is this thing, the toggle or the T. And this one is kind of like a load bang, only it's useful for turning things on and off, okay? Basically, when you click it, it'll send out a 1. If you click it there, it'll send out a 0. And 0 and 1s are used a lot in Max for doing stuff like turning on DACs and things like that, okay? So that's kind of a useful thing, all right? Now the numbers, okay? There's 3 different kinds, okay? This is the one we use most often. It's an integer. This one with a period in it, that's a floating point number, okay? Now, if you take a floating point number and run it through one of those, it'll turn it into an integer, which means you'll lose the decimal part of it. If you take this and run it into a floating point, it'll add decimal stuff to it, but it'll be 0.0000, okay? This guy is a special guy. It's hardly any utility at all. It's for looking at audio signals. Now, bear in mind, audio signals are generating numbers at 44,100 times a second. So it's not that useful. There's another object called snapshot, where you can say, just give me a picture of the audio signal every 100 milliseconds or something. That can be useful, but yeah, it's kind of ridiculous, okay? These, yes?
Question kind of along that line.
Sure.
Is there a way to turn, like, if you have a floating point number that's constantly changing,
yeah,
like converting that to an audio signal?
Actually, maybe if you run it through that signal tilde object, it might do it.
Okay.
I don't know. But there are ways to do it.
Okay.
Maybe there might be an object called, let me try it, signal tilde. Also, as you start to type, like it starts to do stuff, it doesn't look like it's there then, signal tilde. Nope, no such object. Yeah, there are ways to do it. You might have to Google that.
Yeah.
Okay. Yeah, but I know there are ways to do it, okay? All righty, numbers, all right. The other ones that are useful that I use quite a bit are these sliders, okay? And these are useful for, you know, I've been using, just for the sake of making things simple in class, I've been using numbers and just like clicking and dragging, okay? But a lot of times when I'm actually making a patch, I will create a slider, okay? And I'm going to use this to show you some other stuff where this sidebar thing is useful. If I hit that and I go to View Inspector or Command I, it tells me all the stuff about this slider, okay? And you can do all kinds of things, and you can do orientation. You can make it vertical or horizontal. Now notice when I made it horizontal, it didn't change its characteristics, so you have to like spread it out like that. Or you can simply just, yeah, do automatic, which is the default. And as you move this around, it'll change from vertical to horizontal slightly, okay? This tells you like how big it is, things like that, how thick it is, the colors, all kinds of cute stuff like that. But the thing that's really important here is this float output and the range and the output minimum and the output multiplier. These determine the numbers that come out of this thing, okay? So let me select float output. And that means that I'm going to bring down a floating point number, and we'll be able to see it. Now, if I close my patch and I move this, it goes from 0 to 128. And in fact, that's what it's telling us here, 0 to 128. And the output multiplier is 1, so it's going to try and hit all those numbers in there, okay? Now let's say I want it to go from 0 to 5,000, okay? I can do that. All right? And now, as I move it, it goes 0 to 5,000. Now, it's missing a lot of numbers because it's not big enough to account or to sort of countenance all 5,000 of these things. That's why that output multiplier is kind of useful, because you can get control over you know, how you want the numbers to be laid out along the slider, okay? Like I might make the output multiplier 10, That means I'd have 500 pixels along there that I could use, okay? Some of this other stuff, I don't even know what it is. Output minimum is useful, okay? I can change that from, if I want to go from 1,000 to 5,000, now it'll go 1,000 to 6,000. Why? Because the range was 5,000. So just take your output minimum and go from there. So I'd have to change that to 4,000, okay? Okay, useful things to know. Yeah, you can really waste your life, you know, fooling around with the colors and things like that. You know, a lot of people do. It's a good way to not do stuff. I'm really good at that too. Okay. All right. So that's kind of the basics of these utilities and stuff. Oh, God, I don't even know what that does. It's got like a giant paint bucket.
Kind of photoshopping.
Doesn't it though? I'm reluctant to click it because it'll do something terrible to me. Okay. Yeah. Oh, these are the things. This will turn on those different presentations and stuff like that. Okay. I forgot. That's where they're looking. And you also do have an output thing over here. Okay. Also, I want to mention in the sliders, there's a couple of specialized ones. This one, gain tilde, that operates on audio signals. It's very, very useful, okay? And this one, the K slider, that's the thing that actually has a piano keyboard. And you can put that up there and like generate MIDI notes out of it and things like that. You can see what you can do. Again, if I option click on it, it gives me like all the information about it. Okay. Cool.
Can you play chords more than one note at a time on it?
Yeah, you have to change. Oh, look, chords.
Oh,
that's what you do.
Great. Wow.
Okay. Yeah, what do you know? Yeah, I didn't know that. Oh, cool. There's also a way that you can like, well, you can't really do that. Never mind. There's not a way you can do that. Okay. All right. There's one thing I'm looking for, and I can't find it. It's really, really, really useful. Jesus Christ, where is it? On a slider. Yeah, we'll look at it in a second because I know how to find it, okay? But I want to teach you about some more objects. Ooh, my thing went dark. Hold on. Now, those are kind of like the specialized sort of objects that do graphical stuff and things like that. The generic object has a particular format. It has the name of the object and then any parameters that you want it to have when you first start it, okay? And I'm going to show you one right off the bat called root, okay? Select outlet based on input matching. Whoa, what does that mean? I don't know. But if we open up the help, it'll tell us, okay? What root expects you to do is type in things where if it matches that thing, it will print it out of the corresponding sort of outlet. Or if it doesn't match anything, it'll print it out there. So I'm saying root 1, 2, and W. Now, here's what's interesting, okay? When Max gets messages, it looks at the first part of the messages to be a selector, okay? So like I say root 1, if it sees a message coming in and the very first part is 1, you'll say, oh, I've matched it. I'm going to send it out here and I'm going to print 1. Okay, let me bring up the Max console here so you can see it. Okay, oops, get rid of this nonsense. So if I click this guy, boom. Notice it says 1.45. The only stuff that actually came out of there was 4 and 5 because it strips off the selector, okay? So if I say 2, wash the cat, 2, it should come out, it should say print 2, so you should see 2 and then wash the cat. There you go, okay? And again, notice that the 2 that was associated here in the message with wash the cat has been stripped off. Or W55, there, W55, okay? So this is really useful. A lot of times what you use roots for, that I've been using it in some of the patches that I've made for class, is I'll say root bang, and then like float, okay? So if it's a bang, it'll come out there. If it's a floating point number, it'll come out there. Everything else will come out there. That's how when I send stuff out through the RTC mix patch, and I'm sending some numbers, or I'm sending a bang, I use root to split them apart. So the numbers will go to like processing and plot stuff, and the bang will maybe circle back around. Okay, so that's a really, really useful sort of thing to know how to do. Okay, the next one that's kind of the inverse of that is an object called select. Okay, and select, bring up the help for it. Okay, you give it a number here. Okay, and if this then matches that number, it'll send out a bang. Otherwise, it'll send out a reject number and a bang there. So if I type in here 59, notice that it did this. But if I type in here 61, oh, it matched 61. The default I set was 22, or they set. So that when I first started this up, it would match 22. But you can override that with this thing, okay? So select is a way of differentiating and allowing only certain sort of messages to come through, okay? All right, that guy. Another one that's similar to this is a one called gate, okay? Bring this up. And basically, you say a number that determines how many outlets there are. And if you have a 1, it'll send stuff out that one. A 2 will send stuff out that one. A 3 will send stuff out of that one. And 0 sends nothing. So I can sit here and just, type numbers. Nothing's going to come out here. Nothing should come out there. Why do things come out there? Oh, that's weird. Oh, yeah. For some reason, the Metro is doing some bad things there. Let me get rid of that. Okay. Yeah. Okay. So, yeah. Let's open, right now it shouldn't send any out. Let's open up the second outlet, and now it's not coming out. Why isn't it coming out? It should be coming out. What does that Metro have to be? Open the first outlet. No, this isn't working.
Does that number just control the outlet number?
Pass an input to an outlet. Open the first outlet.
Oh, so it's doing the counter 500.
Oh, that's right. It's sending that number out. This is just like determining things. The number that you send out comes in here. That's right. So this will open the second outlet. Ah, right. This will open the third outlet, and this should turn all of them off. Yeah. Okay. Yeah. See, I know what I'm doing. Okay. Okay. And there's also, like I said, there's a graphical version of this called G-Gate. Okay. It looks like that, and it will switch your input this way, and it can switch your output. I'll let you look at the documentation for that one, okay? All right, there's a corresponding one to gate called switch, okay? And switch will accept messages from a specific outlet. It won't send it out, it'll accept the messages. So if I say, give me all the stuff from inlet number 2, and I do this, oh, see? But it won't give me any of the stuff from the other guys. No, siree. Give me all the stuff from inlet number 4. And then, whoa, or inlet number 3. I miscounted there. Whoa, why isn't that working? Boy, this is really useful, isn't it? Oh, because it's up there, inlet 3. Right, there we go. Whoa, yeah, I was just like doing the number. That's not going to help you. Okay, so again, these are all these things that I'm showing you are things for like routing the signals and getting stuff happening, And there's one that's you'll see a lot of that's really useful, and sometimes it can be very frustrating to figure out what's wrong. It's called S or send. A lot of these you can abbreviate, and let's say send to the receiver, okay? And then I can have over here R, the receiver, okay? And let me put up a number thing here. Put up a number thing here. And watch the magic that happens. Well, that's not a number thing, that's why. It's an object. Let me put up a number thing here, okay? I. There we go. And now the magic will happen, see? Why is that useful? That's so that you don't have like patch cords running like all over creation in your patch, you know. The really hard thing is that if you've got this, trying to figure out where the heck that thing is. Max is not really good at debugging stuff, you know. I think if you double click on it, there's some way to actually highlight the receivers, because this will actually send this information to every single R, the receiver there is. So you can have multiple places where that data is going to go. Okay. But yeah, I thought that would be kind of a useful thing for you guys to know about. Yeah, I just want to show you two more, and then just kind of show you one that you haven't seen yet that's highly related to one you've been using a lot. Okay, these are a bit more complicated. There's one that's really useful called call, okay? Stands for collection. And basically, what this does is that you can give it information, like notice this is 1, 2, and 3, and then there's stuff following it. Let me click on these, 2 and 3. Now, if I double click this or I hit open, it will store all those values. 1, 2, and 3, that's your index, and then next to the index is the stuff that you give it, okay? Notice that they're all separated by semicolons too, so that when I now say, give me, say, number 2, boom, and out here in our Max window, notice that it printed that stuff from number 2. That's because this is referring to that same help call, okay? That's like a nebulous thing inside that stores all this stuff, okay? I'll be honest, we haven't used that at all, I don't think, in this class, but you might see this when Pierre and Ted and when Federico shows this stuff, so I wanted you to be able to see it. Now, there's one thing about call that you have to be very careful about. Suppose that you've used it to store a whole bunch of information about like major chords in a scale that you're going to retrieve in different ways, okay? Let me go over here and get my inspector going. And if I, that's the call reference, get my inspector going, and we'll look at the call, okay? There's something, and the default, I think, is just really, really wrong, okay? Way down here, the very last thing says, save data with patcher. If that isn't clicked when you save your patcher, all of your call stuff disappears. So many, many times I've spent like 20 or 30 minutes entering a bunch of this stupid data, save my patcher, come back later, open it up, it's all gone. So you've got to click that. Why they didn't make that the default, I have no idea, because it's just annoying, okay?
I've been in the same loop.
Everybody has. It's just wrong.
It's terrible that this is not the default.
No. Okay, so again.
I thought you had to save the coding separately. I was confused about that. I didn't realize it was saved within the Max.
Yes, no. Yeah, that's because we did it right. If you work up a big RTC script and you save your patcher, again, unfortunately, that doesn't happen on Windows. Oh well, that's a little trickier, okay? All right, and then I'm going to show you one more object that's just insane but really useful. It's called the ZL object. And notice that already it's telling us it must be a symbol. You have to tell it something. ZL is actually a giant bunch of objects for doing things to lists, because Max MSP really doesn't know how to handle lists very well. And notice that there's the basic ones here. Then there's the F to ME. There's the MTH to RC. Notice that MTH, mth output, reverse, okay. There's the R0, rotate to ST, stack. So these are all the different things that the ZL can do, okay. ZL basically stands for Ziccarelli's lists, because the guy that made Max MSP, not Miller Puckett, but the guy who founded Cycling 74, David Ziccarelli, just started doing this because he needed it. And he just added more and more and more and more and more to it, and never changed the name of it. But this is actually a very useful object for kind of fooling around with lists of stuff that you get out, which might be useful for you, especially dealing with data and stuff like that. Okay. Then the very last thing, and then we're going to turn it over to Nicola, is you've already seen this one called EZDAC tilde, right? That's the thing that turns audio on and off, right? Okay. There's another one called EZADC. So instead of being a digital to analog converter, it's an analog to digital converter. Notice it's got a little microphone there. This is how you get audio into a max patch, okay? And it will look at your options up here, your audio status. That's where you set your input device and your output device, okay? So right now it's going to come from my built-in microphone. And this is the thing I was looking for that I can't find. I'm going to bring up the documentation for this, okay? Yeah, see those things there? They're really visual meter tilde. That's what it's called. Okay, I didn't know what it was called. Silly me, okay? Let me bring this up. This is really useful if you do anything. If you type meter tilde, like, it basically turns into this little thing here, and you can make it vertical or horizontal. We'll just do this. And if you put input into it, that's not where it goes. If you put input, maybe it does. I guess it does go there. Yeah. Okay. So now, if I turn this on, it shows me what my sound level is coming in through the microphone. And then you could put in the gain tilde thing here, and you can adjust it. You know, so this is really, really useful. And I'll be darned, I can't figure out why I couldn't find it up there. Hey, Nicola, do you know where the meter tildes hide out, or you just like have to type it in?
Well, there is, you see under the live objects, that's where you can find it.
Ah, the Max
Yeah.
for Live objects. Oh, the ones
You
that I
see
never
there. Yeah, one, two further to the right. Yeah, this one.
There you go. Yeah, but that's the live
one to the right.
meter. Oh, but that's
No,
not
the one to, what is it? Ah, no, sorry. What is it? No. Wait. Wait. Is
Okay.
it? It's up there in one of those.
Yeah, that's what I thought, but I couldn't find it.
There is live.line, or you can find it under the plus.
In the plus sign.
Under the plus,
Oh,
and
look
then
at
under
that.
audio.
Oh, I thought that was only for adding new objects. Look at all of those objects.
Yeah,
Oh,
and
there
there
it
it
is,
is.
meter tilde.
Yeah.
Yeah, this is the place I was looking for all of them. Yeah, images. Oh, look at that. You can have like a pencil. You can have a thing that says hint on it. Or you can have a thing that has like mountains in the sun or a moon or something. Oh, and there's all the jitter ones, yeah. Oh my gosh, yeah. Oh, I thought that was, I never even looked at it because I thought it was just for adding new objects to it. Silly me. Okay, yeah, that's really useful. Okay, and in fact, this encompasses all these others too, you know, so you can use this to kind of like find your, and in fact, you'll notice that there's actually even like a different meter tilde thing here. There's level meter tilde, you know, which is like, you know, makes it look like you're in a real recording studio. Or this interface. Yeah. Go ahead.
One thing that's interesting to know about the live objects, so the one with the dial that we were before, if you build a Max for Live object and you want to be able to map certain parameters and stuff in Ableton with the MIDI mapping or key mapping function of Ableton, Ableton only recognizes these objects for mappings. So that's definitely a good thing to know when you build Max for Live objects, that at some point, with those points where you want to be able to do the mapping, you need to use those objects for Ableton to be able to map them.
I only know about Ableton as working with a keyboard. Is that what you talked about, or is there something else?
A lot of people use the keyboard. A lot of people use it with all kinds of interface devices. It's really popular with people doing techno music. And actually, it's a really useful program. I shouldn't diss it because it's actually very, very powerful.
Yeah, maybe buy
Yeah.
another keyboard, but I didn't.
Yeah, yeah, you can do a lot with it. It's a powerful program. You know, so for interactivity and doing live stuff, you know, this probably Ableton is the one of choice for most people. Okay. All right. So that was my quick tour of fun objects that you might want to know. Gosh, it took me a little longer than I thought, Nicola. Sorry about that. You doing okay?
Okay.
Okay, we're going to turn it over to you now, okay? So let me figure out, how do I stop my screen sharing? Up there, I think. Oh yeah, stop share. Okay. So
All
Nicola's
right.
going to show us like cool AI stuff again. Okay. ML stuff. Yeah.
Yeah. So the kind of things that I want to look at are coming out of. So last time we
Yeah.
looked at.
Hey Nicola, did you share
Yeah.
audio too when you did this?
I'm doing the audio share through Loopback, so it should
Oh,
be
okay,
fine.
okay, yeah, you're cool then. You're cool then. Yeah. All right.
So last time we looked at the objects that you can find in ML star, and today I want to look at those objects that you find in MuBu. MuBu also, so the acronym stands for multi-buffer, is developed by people at IRCAM at the Sound and Movement Interaction Group. You can actually find them also online here. Yeah. So this is the group that is developing MuBu. And as far as I understand, really a big interest to them is finding ways of having a meaningful interaction between movement and sound based on machine learning. But you can certainly do a lot within sound only or movement only with those. And it has definitely found quite a wide audience amongst like the computer music community. And I just want to go through some of those things that it offers, and also show you 2, 3 sort of things that I've done with it myself. So let's get started. Just like for orientation, so if you happen to open this, you find it in the package manager, and then when you open it, it's actually, I think it's quite a helpful design in that it tells you through those different stages here of like first the core externals, and this is the multi-buffer being the first, and then you can choose those different core externals to the processing, different objects for processing, different machine learning objects, and then 3 different sound synthesis objects. And we will look through some of those options, and but you can also go back to the package manager and look through these yourself. I've been working with this for a while, and you really keep on finding new things inside. It's quite remarkable how many different sort of possibilities there are inside, and also you think you know it, and then after some time you find a lot of other options that you can realize with it. So it's definitely also something that you can sustain interest in for a while, I would say, because it really offers a lot of options. And here again, you find an overview on the externals of the core objects, the synthesis objects, machine learning objects, and then the audio and motion analysis objects. I'm not really looking into the sound synthesis much today, because then we're getting too far, but basically you have granular synthesis, concatenative synthesis, and additive synthesis. And yeah, we will be using mostly concatenative and granular synthesis for the examples that I'm showing you. Yeah, let's get started with that. And let me see. I still wanted to say that about the number object. You can actually change this in the here in the on the side. You see, you can change what kind of number object it is, and you actually can also choose MIDI, for example, binary, octal, and hex numbers. And that can be sort of helpful, but for some reason you cannot convert the non audio signal number objects to an audio signal number object via the inspector. But within these, Here you can do a lot of conversion, which sometimes, you know, you send numbers and you think like, why does it not go through with floating numbers? Because the default, if you type number, is always that it is, and it only sends integers, but not floating point. And then you find this after some time. Anyways.
Right. And that's a problem, because if you try and send like 0.13 through an integer object, it'll be 0.
Exactly. Exactly. One of those other default settings that you don't quite, or that at least I don't quite understand, but okay. So let's get started very simply by just recording sound into the multi-buffer. And now the interesting thing with the multi-buffer is that it can record sound and also data input. It cannot record video input, but you can control video with it. I will also show that to you at some point. But generally speaking, having the option of having an object that is able to record sound and then also other kinds of data input, also record MIDI inputs at the same time, is a really potent sort of tool to have. Okay, so we have our audio input set, and I can type record, and now I'm recording audio. And you can see here, this is the synthesis, and I'm using the concatenative synthesis object. I could just change this if I wanted to be grain by just typing granular. And now it's the granular synthesis. So you can actually change between those quite easily. Okay, and now the interesting thing here is that I can, you see, yeah?
Yeah, I'm going to explain. Granular synthesis is taking very tiny amounts of like an audio signal, usually a sine wave, and using that to reconstruct the original sound. Concatenative synthesis is taking like, generally it's like very tiny samples and mashing them together in time to create, you know, the sound that you want to hear. So they're both very powerful techniques, and they do really cool things. So yeah.
Yeah, and I mean, to my ears, I mean, that's already something that I think they have done pretty well with MuBu, is that both of these objects sound really good. So really just on the level of how does this synthesis sound, I think these are two fantastic objects already. Okay, but you see here, it has created these kinds of marks here, which are based on, you can see on the audio threshold. And now I can jump between these different spots. Okay, why am I not hearing that? Are you hearing this?
Seeing it.
We should be hearing it.
Ah.
Let me close this again, open it again. Okay, let me record again. Yes, I'm recording a little bit of sound. Now we should be hearing something, and I can see that we are getting some output, but why am I not? Are you hearing this?
No. You might want to put in a meter tilde and take a look and see what's coming out.
No, I can see this.
Oh, you've got it down there. That's right. Yeah, we can't see the chat there. Yeah, down there.
Hey, give me 1 second.
Yeah. He's looking down here. You can see it.
There's no output from Max. There's no output.
We can barely hear it.
Oh. Okay, that's not so successful for the start. Let me try to open the next one. Maybe this works. Otherwise, maybe I'm just restarting Max. Let's see what's happening here. Is this helping? Yeah, this works. Okay. So this is basically the same idea. Here now that we can record sound into the buffer, I'm going to talk about the whole machine learning and processing part. But first, the interesting thing is that it offers you the possibility to, in real time, actually record audio and also play, which is pretty powerful already. And now what we can do is now I stop the recording process, and this output here now tells the synthesis algorithm which part of the buffer to play.
Nicola, we're not hearing it.
Oh, still not.
No.
Okay, good. Thank you. 1 second. Why is this? That's really. Why is this not working? Give me one sec to figure out what's going on. Okay. Okay, now I figure out what was the problem. I'm very sorry.
Zoom is listening to the wrong thing.
Yes, exactly. So we are doing this, and now you should be hearing it. Actually record audio. Actually record audio and also play. And also play. Record audio and also play. Actually record.
Yeah, we're hearing it now, Nicola.
Okay, and also play. Actually record.
Okay.
And also play. Actually record. Also play. Actually record audio. Okay, and now let's try this again. Now we can actually record my voice and this at the same time have a drum beat play, and I record this. Okay, so now I'm recording this for a little bit longer, and you will see it records the drums and the voice at the same time. So now so this is just basically you see, this is just random. So just jumping randomly right now in between the different parts of the buffer. Okay. And now what you can do, so now this is, we get the video part in.
Hey, Nicola, I didn't hear any drum beat or anything. I just heard your voice.
Really?
Yeah.
Does no one hear the drums?
No, I don't think so.
No, just a scrambled voice.
Okay, wait. What is going on? Because it's definitely here, but it's synchronous with the voice. You don't hear the drum sort of timbre.
Is there a way to play the drums just by themselves?
I can record them again just by themselves. Okay, 1 sec. Let's do this. Oh, it's just the drums.
Not
Okay.
hearing
Okay, I know what it is. Oh man, Zoom. That's incredible. The noise cancellation of Zoom is really filtering the drums out.
Oh my! Right, because we heard.
That's very fast. Incredible.
We heard a little bit, and then and then it, yeah.
Okay, so let's try this again. That's incredible.
Oh yeah.
Man, that's unbelievable. Okay, not bad.
Their algorithm worked pretty well, didn't it?
Yeah, that's remarkable. So now we know it's good work. Okay, let's try this again. So now I'm recording my voice and drums like this here. That's incredible. Very good. Okay, now we should be hearing it. Okay, very good. So now check this out. Now you can actually, now this is where it gets fun. I can now use my camera here. That's my laptop camera you see over here. And I'm not gonna get too deep into this, but basically what it does is it does color tracking. Oh, now it's tracking my glasses. Now check this out. I can control this part here by moving the red piece of paper in front of the camera. Like this here. This here. Very good. This here. Okay, so much for that. But that's already, I mean, it's actually, I mean, you can, I have to be careful with it. You can go into several dimensions with it, but there's already so much potential in being able to actually route certain positions of an audio buffer to specific inputs of camera, or as we will see later, also movement. And I think that's already something that's quite interesting about it, is that it has different locations of a buffer that are retrieved from the actual buffer content. So if I would be doing this with a usual buffer and then a groove object, which is sort of the standard object to play a buffer in Max or SF Play, but Groove has more like synthesis options and stuff. I would not be getting any information about the audio content in a way that would make it possible for me to actually refer to the content of the audio buffer. Here you see the sort of points that it creates are related to the zero points in the so yeah, it's working with a threshold. I can show you. There's a nice overview that they provide.
Hey, Nicola, there's a question
yeah.
here. Ioana's got a question.
I was wondering, how are the drums in what you showed us connected to the input, or is it just something very different and the drums are just, I don't know, randomly generated?
So the drums now, it's a drum beat that's just going on, but it's recorded at the same time as the voice. It could be anything else. It's really just that I came across this earlier and I thought, oh, that's sort of an interesting sound. Because of course it tries to analyze both audio signals at the same time. And then all the onsets for the voice are very much mapped to the text of the drums.
Okay.
That's so cool, thank you.
Yeah, that mapping, that remains fixed, so that each phoneme that it identifies would also be matched to a particular drum hit?
We are not at the level of identifying phonemes yet. We can do this. We could do this.
We'll just say onset.
Yeah, exactly. It's just the onset.
Right.
But really, at this point, what we are looking at is a mixed onset of the drums and the voice. But of course, because the drums is so like clear in its onsets compared to the voice, the voice becomes like pretty close to the drums in that.
Yeah. Interesting.
Okay, so now we're getting into the processing part, and I should say that it really so the MuBu .process objects has a lot of different sort of options of how to process a sound. We will be looking into this a little bit in detail in a short while. Let me do this for you. Okay, and you see that it analyzes the audio. So this is sort of usually how it looks, and it does have a lot of different modes of analysis. And sort of the cool thing is that you can load audio and have it analyzed at the same time. And that also works now here. People, that means plugin interface for processing objects, can also do this with other data. So there is a people object and there is a people tilde object for audio. And that gives us the possibility. Now here, this is the catalog of the different kind of people functions that it can perform. And there's a lot to this, really. Something that definitely I like using quite a bit is this people.mfcc or people MFCC, because it can perform a mel frequency capstral coefficient analysis in real time. So let me talk something here. Okay, you see, so now it's doing the mel frequency analysis, and you can also do this with a buffer. And here you see it's MuBu.process MFCC. And now it performed an MFCC analysis of the content of the buffer. So now the interesting thing is, let me do this. Sorry. Let's do this. Now I can read a whole folder of audio files. Sorry. Okay, I will show that to you later. There's something disabled about this object. You have to, but the point here is that you can load in a whole folder of audio files, and it can perform a ML frequency analysis of all these objects at the same time. And then it enables you to jump between those. We will get there.
Wait, Nicola, I think you're going to have to take about a minute and explain what a ML frequency epsilon coefficient analysis is and what it gives you. Okay, because a lot of people don't know.
Yeah, I mean, maybe you can say more about the history of this. I can definitely tell you that I think the idea here of how it's used is to have a spectral analysis of the audio signal, which is somewhat related in its frequency bands to human listening psychology.
Yeah, it's like an FFT that's souped up for perception. Okay. Now there's a whole bunch of these different things. If you're really interested in this stuff, this is all part of an area they call music information retrieval, which is like the analysis of music and stuff like that. And there's a super app made at Queen Mary's University called the Sonic Visualizer. And it's free. And there's literally like almost hundreds of these different kinds of analyses that you can perform on audio that gives you different information. Yeah, like I said, Nico's using this one because, you know, it is close to perception and how we actually hear the sound versus FFT, which is just kind of like raw stuff. And that's where the machine learning comes in too. Like even knowing how to segment that stuff into those little like onsets, you know, that's something that's not trivial. Oh, there it is, the Sonic Visualizer. Yeah, it's pretty amazing. It has all these plugins you can add. But yeah, if you get into this, it's really powerful and really fun.
Okay, so this is a lot of different sort of processing options for audio signals, and not only audio signals that you have. And that's something that, I mean, that's still not the machine learning part of it, but it's definitely a very powerful element of what you can do with it. Because if you have the possibility to analyze incoming audio signals and other streams of data, it really enables you to perform a form of feature extraction that then makes it possible to find an orientation in the material, which is quite productive, and, for example, makes it possible to view an audio corpus not from a linear perspective, but from different kinds of perspectives, which we will get to. Let me just show you this here. This is the Segmentation Lab. You also find this in the tutorials of MuBu, and this really sort of shows you different. Let's take this. So here now I loaded a sample in here, and there you can play around with different sort of processing algorithms. So here is, for example, the MFCC algorithm again, ML spectral flux, Yin, which is a pitch extraction algorithm that also is specifically developed by IRCAM. I think the last week I showed you Fiddle, like very quickly. It came up in one of the examples, which is a pitch tracking algorithm developed by Miller Packard. Now, Yin is one that is developed at IRCAM and that they use in different processing tools, and so also in MuBu.
Nicola, is MuBu free?
Yes, it is.
I thought Yin had a licensing fee associated with it.
I don't know, but you can just get it like that.
Great.
Yeah.
That's wonderful.
Okay, so let's calculate this, and you see you get a lot of sort of output here, and you can actually now see here. I can choose to view different elements of the yin analysis. Here, this is the markers that it sets. Feature. It's the raw tracking. Here, this is the raw pitch tracking of the yin algorithm. And you can do all those different things with it. Well, let's look at the loudness. So here I click a bang, and then it should be analyzing the loudness. Wait, maybe I need to do this. Let's try this again. Why not? Okay, let's try this one. Oh, it crashed. Okay, well, let's try this again. But it's, I mean, this doesn't look like so much yet, maybe, or you might still be asking yourself, okay, what are we doing with it? But I'm just sort of starting from the processing part to sort of give you an access to like the way that you can look at material to then see what sort of like productive agency machine learning can have in this. Okay, let's do this again. I hope this is working this time. Why is it not? Let's try this again.
You have to select it.
So, huh. So only the yin one is working right now. That's very interesting. That's not so impressive right now. Let's see. I don't understand. Ah, okay. Now we got it. All right. Okay. Now we have sort of an overflow of information. But really, there's so many sort of different processing algorithms that you can use in order to analyze audio and data input. And that's sort of the point that I want to make here. Okay, now let's get into the machine learning and the more interesting stuff. So this is one algorithm, the KNN algorithm. I already mentioned that last week because the ML star package also offers K nearest neighbor analysis, but certainly what MuBu does is it offers the possibility to do this with audio material, while ML star only does this with different kinds of data, but not with audio material. So let's get into this. Maybe I need to set up the, yes. Okay. This, did you hear this?
Yes.
Pretty loud. Okay. Let me turn down the volume. And now, this is what you see here. This in this MuBu buffer. So this object here is a drum sample again that's loaded in there, and the sort of visualization you see behind is also an MFCC analysis. And this MFCC analysis runs through a KNN analysis, which then is able to map out the distance between the results of the different MFCC analysis results for different parts of this buffer. And now I can sort of give it an input. I can feed it an input, and you can see how it jumps through the different parts of the buffer. And so the KNN is really the machine learning element here.
So basically,
so
when you get the input, you're going to be just sort of traversing the nearest neighbors the KNN found then, right?
Exactly. It compares the input to the material that is saved in the buffer, and then it's jumping between those. And now it's also using the concat synthesis. Okay, let's do this. Right now there is not much. Okay, let's play around with this a little bit. Doesn't find so much. Maybe I need to turn it down. Ah, yeah, here. So this you're here. It's sort of about to hit something, and this is the part of the buffer that it's playing right now, because this is sort of the closest result here in the buffer to this input. But now when I change this,
Oh, wow.
and you see how it's jumping around different parts of the buffer here.
Yeah.
And this is the descriptor for this part of the buffer. So, and you can see the, you see, so this is the this is the MFCC for this buffer here, and this is my input. And so it shows me the buffer that it finds. Because it can, so basically here, this is the data index for this specific part of the buffer. Then there's a buffer number. We will get to this later when we jump between different buffers. And here's the distance between this here and the input. And let's do this again. And sort of the cool thing is now I can use the people object and perform a male frequency analysis on my voice, and I can route the output of this into here. And now you see I can speak and play the drums with that, actually by speaking. I mean, of course now it's getting sort of pretty rough results. Ta! Shh! Huh, okay, wait. We have, maybe I should be deleting this. What happens now? Yeah, okay, let's change the weights. Let's change the weights a little bit. Oh yeah, now we get different results. Ah, okay. Yeah, ah yeah. So it's sort of a combination between the input and the weights, really. Let's see, and that really makes you find different things in the buffer. Maybe this buffer isn't so amazing right now. Let's see.
Right now the buffer just has some drum samples, right?
Exactly, it just has a drum sample. So let's try something else. Okay, so that's the guitar. Maybe that works better. That's the guitar sound. And now I'm basically jumping through this guitar sound by speaking, which is also sort of interesting. Of course, by using different analysis tools and by linking them differently, you get quite different results. But I think you get the idea. You can really use a different kind of audio input and analysis of that to play a different audio sample.
That's amazing. It's amazing it does it in real time.
Yes, exactly. And that it works in real time is very, very potent aesthetically. Okay, let's go through this. So I made something that gives you the possibility to actually work with several buffers at a time, and maybe that's more interesting now. So I can actually load a whole folder into there. So read folder is sort of the command that it needs to load a whole folder.
I like your too much samples.
Yeah. Okay, so now we have all those samples in here. And you see, this is the MuBu.process and then source audio MFCC. So that's the analysis that I'm now performing on the audio material. And you see, so now it did a MFCC analysis of this. And now what we can do is this. Now I'm using my audio input. Let's do this here. Yeah. Okay. Now we are getting the audio input, and probably we are hearing something. Yeah, we do. Okay, let's see. Yeah, play gate. 1 sec. That's someone. Let's see here. So the tricky thing with this G-switch objects is always that when you load it and you don't give it a load bank, you need to click on them once for them to be on. Otherwise, there's just nothing coming through. And I am trying to find out what is the problem here right now. Ah, yeah, okay. You see, I can talk and it's really, the guitar is following what I'm saying, which is sort of actually quite interesting because you can create very different sort of connections between different kinds of audio material. And now I can also tell it to be only using specific materials from the buffer. So here I can regulate. Now it's only using one file from the buffer, only file number 20. And now, for example, only number 12, or number 11. And now it's all again. And I can change the weights again. Here, so this is the weights. And that changes the interpretation. Or I can use this one. Maybe you remember it from last time. So that is the ML sum that I showed you last week. And of course, I can also use the output of ML sum, which is now, again, like last week, you see here is ML sum is doing, again, a spectral analysis of the incoming audio signal that comes from my voice. And I can use that to actually control.
Is that a Cohonan feature map then that it's generating?
Yeah, that's the self-organizing map.
Yeah, that's a Cohonan feature map, yeah.
Yeah, exactly. Yeah, but I still need the audio, but you know, you get the idea. Okay, and I'm actually using both here. This is now the granular synthesis and this is the concat. And listen to the difference. So they are both getting the same information for how to synthesize and which part of the buffer to synthesize, but it sounds very different. Look, now here, and this is the granular one. Sounds very different. It's also with percussive sounds, they have a very different quality. Let's see. Ah, yeah, this one is a very good example. Let's see. Yeah, see how different they sound.
Actually, we don't hear that much difference.
Yeah, maybe that's with Zoom and everything, but it's very different once you really start getting into it. They sound quite differently.
Yeah, I'm familiar with both techniques, and they would be very different from each other.
Yeah. Well, I guess everyone has to trust Brad on that it's very different.
Right.
Okay. Yeah, but I guess you get the idea, and that's, I mean, that's already something that I definitely had a lot of fun with the option of playing with an audio corpus like that. Because if you use this, for example, for field recordings also, it's very interesting what you can do with field recordings once you start getting into those sort of things. Now I can also, of course, feed it back to itself. So create a feedback where it listens back to itself again. So, and hopefully, yeah, now we're getting it. This should be working. Oh yeah, sorry. But and that's actually, I mean, it sounds a little bit dull now, really, but when you do this in an actual space, with a microphone and a speaker, it becomes so interesting because it has space to breathe. If just this digital feedback is not so interesting. The really fascinating part, if you do things like this, is that the microphone and the speaker always introduce so much dirt, let's say, into the interpretation process, and so much of the like difference between different spaces, that if you have a sound that is produced and it's directly analyzed again, of course there is an exact match. But if you have the liveliness of a space and the individual sound of a special microphone, of the audio interface, and of a loudspeaker in between, so that the deviation of a material from itself by this process gives it a whole other life.
Yeah.
I don't know. I mean, that's definitely something. I mean, you could try it out. You know, you will have that patch later after the class. Just try it out. Connect the microphone and the speaker, and then you will see where it goes. And it's really interesting where things can go. Also, when you play around with the weights here. Yeah.
Yeah. You can really change a lot just by what you choose as your input analysis too. You know.
Yeah.
Very, very different effects out of it. You know.
Yeah.
Yeah. Amazing. That's really cool.
Okay, we're at 1.2 and we have to get until 6, so I'm going to speed up a little bit. Let's see, I think this one.
Hey, Nicola, if
Yeah.
you need to bleed over into next time, that should be okay, because I think we'll have a bit of time. So
yeah, that's a good point.
Okay. So don't get too carried away. We'll take it as it comes. We got a little bit of time to play with.
Yeah, I mean, there's definitely, maybe I will try to save some things for next time, because the overlaps between some of the things that I have here and Wackinator is quite interesting.
Yeah, I think that would be good to do. Okay.
Yeah. Okay. Let's see. Maybe then we can slow it down a little bit. Let me open this again. Are there questions about this so far? I mean, of course, this is sort of a lot of stuff right now, but I don't know. Is there anything that you want to ask about it?
I think your advice is good to just open the patch and connect a microphone or something and just fool around with those different things that you've been fooling with, and turn up the outputs and turn up another output. Because that way you'll start getting a sense of what it does, and I mean, I'm getting a pretty strong sense of how it works just watching what you're doing.
My one question was, if I wanted to change the duration of the sample that gets repeated, is that just like a parameter in the synthesis? I see the duration, flag there.
I believe that is.
Or is that also part of the analysis? Because it's also part of how you match them up too, right?
Can you say this again? I'm not certain what you mean by.
When MuBu does the segmentation in the analysis, is there a way to control what the duration of the segments is, or on synthesis output? Can you control what the size of the segments
are? Absolutely, you can do. Let me show you. So when you let me just create this, because so that's who is it? Okay, I don't find it right now. One second. So there's all these. The drums again. Wonderful. There is all these here. That was the look. If I connect this here, you see there is a lot of options that I have just there. So that's on the level of synthesis now, where I can, for example, change the, like, let's say if I use the granular one, you can change the size of the grains and all of this. So you have full control over the synthesis process. So that's one level, right? That's really the question.
Output grain position.
How many grains do I get and all of this? So there's a lot of control that you have on that level. But then there is, of course, also the option to change the length of the here. Yeah, duration, for example. Let me do this one again. So duration, of course, is one of these here.
This is all right?
Duration, random variation of the duration, and all of those things.
Yeah, those are that's a synthesis area.
Yeah, this is really the synthesis parameter. So that you can change, and that's also totally relevant when you work with that. You can do all the pitch up and down, and yeah, there's a lot of options that come with these synthesis objects.
And on the, like analysis segmentation side, is it?
I don't know about that. That's a tricky thing. I mean, because it's kind of doing its own thing. I think you can probably change some parameters about how it is approaching the analysis. It would affect that, but I'm not sure you can set it directly. Yeah. Is that true,
well,
Nicola? Can you?
Well, you could totally. Let's see. Here's the analysis part, and you see here's the people.
Oh, there you go. There you go.
That's what
Object.
Okay, that's it.
And that's really where you, I mean, if you go into the reference of this object, well, it seems there is no reference. Wonderful. Fantastic. But you can certainly change this quite a bit.
Yeah.
Yeah. Here you get the hop size and all the different sorts of parameters. And then, of course, there's also always a workaround. If, for example, you wanted to say, I want an update on the result of my analysis only every 5 seconds, well, then there's all these other utility objects that you can use to do this. For example, with a gate that opens and closes only every 5 seconds or whatever. I mean, there's a lot of options that you would have to do this as well, for example. So one thing is what the analysis object provides, but I think the other question is, of course, how do you work with that inside of Max? And there's so many possibilities of how you can tweak this. It doesn't need to be like full on the whole time, or it needs to be real time all the time. There's so many options. I mean, you could also, for example, let's say, I wonder how that would work, but probably it's possible to also say you want to have the audio signal analyzed, but you only want to get somewhat of a median value of this every like 20 seconds. That would also be a possibility.
I think one of the things to realize is at the heart of a lot of these is a Fourier transform, because that's the thing that gives you the spectral data that you need in order to do these kinds of operations. So like you said, the hop size, and things like that, that's going to fundamentally affect how it does it. Yeah. It's interesting. That might actually be a little bit too low level, for what you're thinking about. I think some of the other parameters that Nicola was showing you about the analysis itself, I mean, yeah, you're affecting the FFT, but you want to affect what the analyzer is generating, what it's putting out, I think. Like you might want to have a minimum amount that's like not going to go below in terms of slicing, right? Something like that.
Mm-hmm.
And I think that was those attributes that he showed you earlier.
Yeah.
No. There's another one that had a whole bunch of attributes.
Yes. Where did I find this? Oh. I forget. I forget myself what I did, but yeah.
You have to go back and look at the video. There's one that had like a whole page of different attributes, like slice length, and things like that. Okay. It applied more to the MuBu analysis process and not just the underlying FFT.
Oh yeah, when we first were
right.
Yeah,
right. I mean, obviously the underlying FFT will have an effect on it, but probably not the effect you want.
Yeah, in terms of like the sample itself, like how long is the piece that we're repeating?
Exactly.
Not necessarily resolution.
Right.
Yeah. Okay. All right. So that's this. Now we're getting into something that refers back also to last week. And I didn't show you this part last week, but again, that's something that sort of ML Star offers, but MuBu offers with audio, and that's where I think it becomes really, really interesting. So that's the fuzzy C means clustering. And I can just produce here, so that's again the UC object. I have 300 banks, and it gives me a bunch of random numbers, and I map those out. And now I have different possibilities of doing this and of mapping these out. And I get sort of a collection that is not based on their temporal appearance, but on the value. But what now I'll get is Max crashing again. Yeah, maybe it is.
Looks okay to us.
Oh yeah, but here it's okay. I will quit it. But so now the interesting thing is that with MuBu you can do this not only with numbers, but with audio samples. And that is Kata RT, originally developed by Diemo Swartz. And so this is how it looks here. You recognize the familiarity to what we have just seen. And I can, again, now load a whole folder of audio samples in here. And have those analyzed. And what we get here, you see, is a clustering of different parts of this audio corpus. And so let me play with this. But that's still the...
So each one of those dots is a little sample. And then the
Exactly.
your connectedness, yeah.
Exactly. Now I'm going with the mouse, but of course, it doesn't need to stay there. Now we are getting back to our, where did it go? Here. To our wonderful paper strip, and let's see how we can play those samples with the paper strip. Let's see, but I first need to activate the, where did it go? Actually, I don't need the paper strip for this one. So that's another JIT algorithm now that I'm using. That doesn't track color, but it tracks brightness. And you see now it is a sort of the video analogon to the centroid analysis in audio signals. And yeah, so that's also a way of playing guitar. You see down here how it tracks my my face and the centroid values, and it uses that as XY values for the mouse. So it basically does exactly this, what I'm doing here, but with a video input. So it's graphing along this map. You see here, I'm getting the, oh yeah, what did I do? Exactly, so here we are getting the output from this, so it's still a JIT object, it's still a matrix. And these outputs are mapped as XY value to this object here, which just gives me an X and a Y value, and these go out and give the position to the MuBu, again, KNN corpus, which does exactly the same thing as if I was going around here. And you see some of them are blinking up. Can you see this?
Yeah.
That some of them are lighting up. So that's exactly the samples which are being played. So let's do this again. And you see, now I can change the duration. And as you can see, the duration, again, is a parameter that is changed on a level on the of synthesis. Let's change this to 400. Of course, I could also be mapping this to my head. So let's do this for fun. Let's see. We use a scale object, and you can see what's coming out here is somewhere between 0 and 120. So let's say we map 0 to 120 to, let's say, 20 milliseconds to a second. Now I connect the output of the centroid analysis of the video here, and there you go. Of course, I need to keep moving because it needs to keep on new samples, because once the sample is played, it's done. It doesn't repeat. You can also allow it to repeat. Let's see. If this one works. Allow repeat trigger. Let's see. Yeah. Well, who would have thought that you can play guitar like moving your head around the camera? But that's all possible. Or you could play the drums again. Yeah. So I think that's a lot of really fun sort of possibilities that are coming up here.
Hi, can I ask what is the meaning of the coordinates, like distance?
You mean
and
these here?
I mean,
no, in the CalArts plot.
Yeah, okay. Every dot is like, for example, if one dot is on the point 420, what does that mean?
You see, you can change the way that it displays these up here. So you can see X and Y is loudness, mean. And I can change those, and you see, now I can use centroid.
Oh.
And I can do centroid on both, and now it looks like this. And now it's just a centroid. So the what I said about the image that it tries to sort of find the center of an object. Now, of course, you can do this for sound as well. And then, I mean, it's fun if you have very noisy signals, because where's the center in this signal? It's not so. It's much more difficult to do this than to do this, for example, with a sine wave, where this is pretty a simple answer. And that, of course, becomes a fun way of looking at audio signals. So. Yeah, of course, you can still do the same thing with it, but yeah, you can really change the way that it's displaying, and you can choose the different sort of categories that you use to look at it. Does that answer your question?
Yeah, of course.
Exactly.
Thanks.
The question. Yeah.
Okay. Yeah.
Okay, Nicola, do we have time for you to play some of your stuff, or are we gonna do that next time?
I don't know. However you want. I mean, I can just play some things and maybe show you a short thing that I did with the Buchla over at Columbia that uses a lot of these sort of things. Maybe that's
we've only got about
fun.
10 minutes left in class. I also noticed that it's going to be 2 o'clock in the morning for you over there.
It is, yeah. Indeed.
Well, thank you so much.
Yeah, yeah. Well, I'm lucky I'm not in Istanbul. That would be even worse.
Yeah.
Now, thinking again about your TA 3 semesters ago, he was in Istanbul.
Owner.
That was even worse.
Oh, yeah, that's right. Yeah. Oh, man.
No, yeah, but yeah, it's fine.
I'm just a taskmaster. Yeah, play some. Yeah, let's take a break maybe from this, and we'll finish up some more next time. Before
Yeah.
Combinator, and just show. I think people would really get a kick out of seeing how you use it in performance, or create some music.
Yeah.
Yeah.
Okay. Let me do that. So now, of course, you can, go a little bit further in terms of segmenting audio material. And so this is a performance that I did with the Buchla 100 over in 324. And this MuBu process, which is trained on roughly 3-4 hours of my guitar playing. And it sort of becomes a duo between this like virtual guitar player and me actually playing the Buchla. And you have the same sort of MFCC and KNN process going on that I showed you before. But that, let's say, also works with the segmentation by the audio on-seg. To really be able to develop musical phrases out of this, and really that the whole system is also able to listen back to itself with a microphone and speaker in the space. But it's also really reacting to what I'm doing with the Buchla, and that actually becomes quite fun. So let me show you. Just need to turn on the audio here. Okay, so tell me if you do not hear audio. In the beginning, there's no audio, but at some point you should hear it. Maybe we can spare the text. Okay. And it's using video material as well, which helps to really differentiate auditively what's the guitar and what's the Buchla. Can you hear it?
Yeah. Cool. Wow.
Yeah, I mean, that's just a short excerpt, but I mean, maybe that gives you an idea of like sort of fun things you can do with it. That had no like face moving in front of the camera, but at least it's some music that comes out, I hope.
Yeah. But I love to watch the way you were like getting into the noise. You know, you're kind of like, whoa, whoa, whoa. It's pretty cool. Oh my goodness. Anyhow. Yeah, let's maybe wind it down now, and then next time we'll pick up and finish the MuBu stuff, and then we'll jump into Wekinator after that. Because I don't think the Wekinator is going to be like a huge amount of the class or anything. So, and you're right, there's some nice connections between the two.
Yeah.
Cool.
All right. Pretty good.
All right, well, go get some rest, Nicola, and
Yeah. Thank you.
yeah, this is really wonderful. Yeah, very much so. Okay.
Thank you.
Yeah.
Okay,
Cool.
cool.
Saying 2 thumbs up. All righty. See you next week, and good luck with everything over there. Okay.
Yeah. Thanks. See you. Bye bye.